Why, hello guys, this is Stas, your very good friend from the future, and it's been, I think, about a year since I've done my last tutorials, but you know what? My old tutorials all sucked. It's good that I have taken this time off, and I've been extremely busy, and even though I'm still extremely busy these days, I've decided to take a break from doing horrible cover versions of South Park songs and do a Max tutorial. Except this Max tutorial is not gonna be a regular tutorial, because we're not really going to do something extremely useful. We're going to do instead something extremely pointless, which I came up with the other day. Let me tell you the story. So I was editing a CSS style sheet for a WordPress site of a friend of mine, and then at some point I just got distracted by hex triplets. And let me explain you what hex triplets are in case you don't know. Now, when you define colors for your website, such as no, this is not a website. I don't have a website open right now, but you know how a website looks like. When you define colors, you can do it with keywords such as red, orange, or yellow, and HTML and CSS support that, but the number of keywords is limited, and the grown-up man way to define colors is using hexadecimal notation. Let me give you an example. I mean, I actually have a style sheet open right here, so you can see, hopefully, and if you can't, you should definitely make this tutorial full screen. You can see that the background is defined in funny letters reading FA, FA, FA. And this actually stands for 250, 250, and 250. Let me explain you how this works before we move. Sorry guys, got distracted there for a second and bought myself a caffeinated drink. Moving on. So in the first step of this tutorial, let's learn something about RGB color representation and also something about number systems, because we're gonna need that, trust me. And if you don't want to learn about number systems, I don't know why you're watching this tutorial, presumably because you know me and you like hearing my voice so much, in which case I assume you don't even care what I'm talking about. So we're good. All right, go ahead and make a new object and call it swatch, and voila! We're gonna have a nice graphical color picker in Max, which we're gonna see why we're creating it in a second. And by the way, I'm assuming in this tutorial that you definitely know basic Max stuff, such as how to create an object, how to access its help file, how to lock and unlock a patch, and stuff like that. If you don't, then definitely check out my basic Max tutorial patches, which I'm gonna upload today or tomorrow, and which you definitely should go over before you continue with this. So, alright, so this is a swatch. I don't know why it's called a swatch, but it helps you select colors in Max, and let me just demonstrate it actually. Make a print object, connect it to the leftmost outlet. Whoop, not like that, yeah, lock the patch, mouse around a little bit, and you see now in the Max window, which you should definitely have up, that every time I mouse around inside the swatch object, it sends a list of 4 floating point values out of its leftmost outlet. And the 4 floating point values, they have a range from 0 to 1, 0 representing black and 1 representing white, and they stand for the red component, the green component, the blue component, and the alpha component, which you can basically forget about because we're not, forget about it for now, because we're not gonna need it for the purposes of this tutorial. So, okay, in case you didn't know so far, now you know, and you definitely should know it, that colors can be represented as a mixture of their red, green, and blue and blue components. That's right. And also, this is basically the same way to represent RGB colors, or to represent colors in general, as we have seen before in that CSS style sheet that I was showing you. Except you might recall that it didn't really look like this. It wasn't a triplet of floating point numbers. Instead, it was 6 characters of what looked like letters. Well, in fact, it was 3 numbers, except they were represented in hexadecimal. It was 3 times the same number, which was 250, which is expressed in hexadecimal as FA. To understand this, we need to learn a little bit about number systems, As I said, don't worry about it. We will get through it in no time, and then we will finally start to build our max patch, or yeah, Java external. All right, so I'll make a comment for you, and I'll make the font size a little bit bigger in it so you can see. Let's set it to, I don't know, let's set it to 20. All right, cool. And let's start with the decimal system. Let's start with what we all know and hopefully love. You might or might not be aware, but what we represent as decimal numbers, or what we think of as decimal numbers normally, like the number 123, is in fact shorthand for powers of 10 starting from the right, multiplied by whichever numbers you see in the usual common everyday representation. So 123 is in fact shorthand for 10 to the power of 2 multiplied by 1 plus 10 to the power of 1 multiplied by 2 plus 10 to the power of 3 multiply, 10 to the power of 0 multiplied by 3. 10 to the power of 0 is 1, 10 to the power of 1 is 10, and 10 to the power of 2 is 100. So what you get in effect is 100 plus 20 plus 3. If this is totally new, it's probably the best idea to pause the video right now and look a little bit at what I just wrote down and try to understand it, and then move on once you do. Now, this is the decimal system. Computers, as you may be aware, do not use the decimal system because it would be highly inconvenient to build a computer that uses the decimal system. Instead, it represents numbers in binary. Binary is essentially a number system that works on the same principle as the decimal number system, except the base is different. And what we call the base is what is represented here as this 10. So 10 is the base in decimal. In binary, as the name already suggests, the base is 2. So you would express the number 5, for example, as 2 to the power of 2 to the power of 2 multiplied by 1 plus 2 to the power of 1 multiplied by 0, we don't need that, and 2 to the power of 0 multiplied by 1. If you calculate this, you get 4 plus 0 plus 1, which is 5, or in binary, this is written shorthand as 101. All right, cool. So, binary, awesome. You probably have figured out by this point that to represent larger numbers, we need a lot of these digits. And each digits can be represented as 1 bit, and bits are usually summed up in so-called bytes, which you probably have heard of. Bytes are sequences of 8 bits, and 8 bits can hold 2 to the power of 8 different values, which equals 256 different values. Now, a convenient way to represent bytes in computer science is the hexadecimal notation system. And the hexadecimal notation system is basically, again, it works the same way as decimal or binary, except the base isn't 2, it's 16. So, since we don't have enough digits to represent 16 different values, we use letters instead, and that's exactly what you saw. That's right. So let's calculate, for example, you know what? Let's calculate exactly that number FA that we have seen. A stands for 10 and F stands for 15. So in effect, we get the following. We get 16 to the power of 1 multiplied by 15 plus 16 to the power of 0 multiplied by 10, which equals 240 plus 10, which equals 250. Correct me if I'm wrong in the comments, please. Why the hell do we choose 16? Would we choose 16 as the base? I mean, who in their right mind would do it? Well, it so happens that one hexadecimal digit can hold the same amount of values as 4 bits can. 4 bits can hold 2 to the power of 4, so 16 different values, and one hexadecimal digit can hold, surprisingly enough, 16 different values. So that's why it's so called. So the reason why you saw those 6 letters was, now you probably are beginning to understand, or you have understood long enough, and I'm telling you something completely old here. is we can represent a byte conveniently by a 2-digit hexadecimal number. 1 byte, remember, can hold 256 different values, and so can 2 hexadecimal digits. All right, cool. So now that we have understood everything about number system that we ever need to know, let's move on and consider how could we possibly realize what we want to achieve, namely a convenient picker for website colors, for when we're developing websites. And I'm gonna make this window just a little bit bigger and move this comment over to the right to leave it for you so you can see it's gonna be gone in the next video. But so, yeah, basically, let's open the Max window again and consider this list of values. First of all, you probably have figured out already by now that colors in a 24-bit RGB encoding, which is what HTML and CSS use and which is what a bunch of other things uses in computer graphics and stuff like that, that these colors can be represented by integer values going from 0 to 255, which is 256 different values. And since we have 3 of those components, we can take 256 to the power of 3 and get like over 16 million colors, which we can encode that way, which is more than the human eye can distinguish. So yeah, awesome. So you might think, okay, we've got floating point values here going from 0 to 1. So all we need to do is multiply all of them by 255, right? And then, I don't know, convert them to integers. And then we're done. Well, not quite, but that's a start. So make a V expression object. And all right, wait a minute. V expression is a Max object that can process lists using expr style expressions. And if you don't know what those are, just look it up in the help file. I'm just gonna tell it one more time. Press Command Shift H or Control Shift H, depending on which operating system you're using, and you get this. Let me show it to you. You get this cool, awesome interactive help file in Max, where everything is explained, and you have most of the time you have multiple tabs, and you can even have links to related help files and related objects. For example, expr is basically the same, but except it processes individual values except of lists. We're gonna get a list, so we're gonna take a V expression, we're gonna take floating point values and multiply all of them by 255. All right, cool, connect this up. Make a print object again. What the hell just happened? All right, I created something that I wasn't really meaning to create. Make a print object again, bring up the Max window, clear it, especially because it says bad expression, and mouse around a little bit, and voila, we're getting floating point values in a range which we can actually use. Now all we need to do is convert them to integer. So I don't know, unpack float. We don't need the last float value because that's the alpha value and we don't care about it. And yeah, theoretically we would now start making integer objects. But consider this. If we do get, in the end, a neat list of values where white is represented by 255 and, well, 3 times 255, and black is represented by 3 times 0, we still haven't arrived where we wanted to arrive, which is hexadecimal notation. And there is a really neat trick to convert decimal to hexadecimal, which we're gonna be learning about in the second video. I promise it's gonna be awesome. And to tell you what exactly we're gonna be doing, we could do this conversion using some clever bit shifting and masking using just Max objects, just this kind of stuff that you see right here. But this is inconvenient, and actually implementing something like that works way better when you use something like a traditional programming language. And this is exactly what we're going to be doing. We're going to be using the MXJ object. And you can see here in autocomplete, MXJ is an awesome object which allows you to execute Java code in Max. Along the way, we're going to be learning something about Java, something about the Java specifics in Max. And in the end, you're gonna have your own Photoshop-like color converter? Yeah, color picker. Let's call it the color picker. All right, cool. So I'll see you in the next tutorial. I hope you have enjoyed this. If you're still watching this, wow, I'm blown away. So see you soon.